Today I'm going to teach you about the law of sines. Sometimes we have triangles that are not right triangles. For example, the triangle that I've drawn here at the bottom is not a right triangle, but we can still find out information using the law of sines. So you'll notice here in red I've written down copy. I want you to copy this, all this in your notes, and it's to find the area of a triangle. So if we know the side lengths of C or A or B, we need to know two side lengths, and then we need to know one of the angles. If we can do that, we can find the area of the triangle. We can find the whole area of the triangle. Or we can use the side of A times C divided by 1/2. Just take 1/2 of it, divided by 2, times the sine of B, or we can use A times B divided by 2 times the sine of C. In any case, that's how you use the law of sines. All right, so I'm going to do a problem for you showing you how to find the area of this triangle. So let's just draw a triangle, and I'm trying not to make it a right triangle, of course. Sorry guys, I had to change that triangle. This one is going to be easier to see. So if I want to find the area of this triangle, I know that I'm going to use area equals 1/2 BC, 1/2 B times C, because I have those two triangles. I mean those two sides, guys, times the sine of A. So all we're going to do is plug numbers in. All right, I like, when I say 1/2, I rather go like this. I rather put B and C up top and then just divide it by 2. So I'm going to say B is what? B is right across from there. It's 17, so 17 times C, which is right across from here, and it's 19, divided by 2 times the sine of A. And when you put all that in your calculator, you're going to get about, and by the way, the sine of A is sine of 135, guys. I'm sorry. Sine of 135 degrees. And when you do that, you're going to get about 114.2 squares for the area. That's your answer, okay? Now, do you understand what I did? Because I had the angle A, then I'm going to use the sine of A. If I had had angle C here, I would have done the angle C, and I would have done 1/2 of AB. If I had had B, I would have done the sine of B times 1/2 of AC. You do the opposites of what they are to find that. Now, if you want to look on your book, it's page 508, if you want to see some more examples. Next, using the same kinds of ideas, we're going to find the side lengths of a triangle that is not a right triangle. So we're going to do the same kind of thing, and I'm going to write down the formula here, and I want you to copy this whole page. These are the three formulas that you might use. The sine of A over the side length of A. So let's say we have A here, and then we have little baby A there. Or let's say that this is B. We have this the angle B over little baby B. Or maybe we have the angle C here over baby C. So you're going to use one of those to solve this next problem. All right, so in this case, I have 115. I know the sine, that I'm going to use the sine of A over 20. And let's say I want to find this side right here, okay? So what we're going to do is the sine of A, sine of big A over little a, is going to equal, let's say, because we know this side, and it's B, then I'm going to have to say the sine of B over 11. So that's going to equal the sine of 115 over 20 equals the sine of B, which we don't know what that angle is. See what I'm saying? So we have to figure this out. Sine of B over 11. Now we're just going to do our cross multiplication like this. So 20 times the sine, you didn't need parentheses here, the sine of B, well, it's okay though, equals 11 times the sine of 115. Now, I want to know what the sine of B is. And when you finish solving that, the sine of B is 29.9 degrees. So now you know that angle, 29.9. Now to solve the rest of it, all you do is 180, take away 29.9, take away 115 to solve the last angle. But that's how you can find all the angles. And then to find this sine, the length of this, you can also use the law of sines.